in terms of the amount of time that it took you to solve? Is that reasonable? So again, with all of the homework, I suggest even when you're the most busy, open up the homework the moment it's posted. Just introduce yourself to what it is that you're going to face, okay? And that's going to simply help you be faster and more effective, both in getting the possible help you need and start thinking about the problem. Just in the back of your mind, even if you're not busy solving them, having seen them, next time you see somebody from the class, you can say, oh, that problem too, have you thought about it? And that will speed you up, okay? So we'll just start the thinking process sooner and rather than later, and that always helps even when you're the most busy. In terms of printing issues or anything, there's one thing that happened to at least 2 or 3 of you that whatever is the built-in, is it Internet Explorer on Windows, the browser, would print only one page into PDF and not all of them for some strange reason. Try downloading a different browser and making that a default, so maybe a Firefox. Firefox works for me, but I also have a Mac. These things just happen to sometimes work different with different systems. So give it a try. The software, usually, I call that a sinusoidal curve. It goes up and down. With different updates, certain things break down, don't work, then they improve, and that's how you ride the wave, okay? So you just have to work with it, because again, it's a dynamic system that constantly updates, so things sometimes work, and then 2 months later they might not. That's the reality, okay? And we all have to deal with it with all different software. This is not unique by any means. And finally, whenever you have an issue, printing or this or that, email the file. Email the file, we know you completed it on time, then you can bring a printout whenever you get to it, like 2 days later is not a big deal. Printing in color is not a necessity either. Again, printers will start as the semester progresses. Printers will have issues. You can count on them going up and down or not having enough paper just when you need it, okay? So good save in this class is that it's mostly computational, so you can still email the file. And to prevent files not being properly saved, the best thing is to have them in the cloud, so there is likely an additional copy. Okay? So again, put things in place that will help you later, right now. Excellent. So let's get back to our plotting. We're going to continue plotting. And I have just basically put together a very quick review of everything that we've mentioned for plotting graphs. First and foremost, for plotting, you need to have points. You have to have a handle on what points are you trying to plot. Without that, you can't start. And it can be as simple as, oh, sine function. Great, everybody knows a sine function. You have it built in, so you can always compute it for a number. But you need to give computer a range of points as well as the sign for those points. So you need to calculate that and give it to computer to plot. How many points? Things like those. That choice is on you. Okay? So in that sense, computers are super smart. They can plot million points if you want them to, except that you have to give them those million points. Okay? So you have to be careful about that. So again, computers are stupid, but they're very good at executing whatever it is that you tell them to, as long as you know how to tell them. Okay? So our basic command, fundamental command, is plot plt.plot. What do I mean by plt? What is that? Matplotlib.pyplot. It's a module that is the most common one for graphs and most developed one. So I will give it x coordinates of points, y coordinates points, and any kind of parameters. If I don't give it any parameters, it's going to do something on its own, which is often good enough. But if I want to control color, type of marker, anything about the plot, I will do that in whatever follows. And there are certain keywords that I can say label equals and then some text that will label my plot. And that label I can bring up by executing legend later. can dress up my plot or dress down as much as I like. If you're an engineer and you're plotting physical values, you better have your X and Y axes labeled, including physical. So if it's length, it's in meters or kilometers or whatever it might be. So you should have to. I shouldn't have to remind you to label them because whoever you're communicating your information, physical parameters do matter. Okay? Title, text, you can place text at a set of coordinates x, y, and so forth. Then I can modify axes. Again, there are certain default choices, so I don't have to do it. Okay? But I can make my plot prettier. And it's often quite important to either add grid, so you can actually quickly find yourself on the graph and make a decision based on it. That's why you're plotting it to begin with. Okay? And it's also often important to make your graph proportional. And you can either put your axis to be square, tight, or equal, or a combination of those to actually have it kind of snapped to a proper grid. Okay? And finally, I often want to compare, and it might be too busy to put too many different graphs on one plot. Okay? And in order to make comparison or some sort of parallel plots, I will use subplot command. I will tell how many rows and columns, okay, that I'm plotting. And then plot index, the current plot index. So if I could have, for instance, 2 rows and 2 columns, and then I'm going to give it indices, 1, 2, 3, 4, to basically indicate what it is that I'm plotting right now. Okay? And then for every subplot, everything that we talked about an individual plot applies. So I can do whatever it is that I want in the subplot. Okay, so let's see whether you remember anything of this. So I have a small assignment for you, and this is going to be that quiz to be submitted tonight. But I would love for you to finish it right now and basically upload it immediately. So create 100 points XY on a circle of radius 1. Plot that circle in red color with a solid line. You can dress up and down anything else after that. But I do want you to find online, by search, however you'd like, how to change the line width to be 2. For those of us who have glasses, we like thicker lines, or else we don't see well. And while everybody is starting to work on it, you feel free to consult with somebody next to you. This doesn't have to be either. If you like working alone, well, work alone. But think about it. How do you create those 100 points? There's no one way, but there is sort of some ways are faster than the others, or more effective than the others. Knowing a little something about how to parameterize a circle would be the best. And I didn't say it, but circle of radius 1 around 0, 0, but it could be around any other point. That's irrelevant.
You can do a semicircle, which is why you can do this, and then you can do another semicircle. And if you set that x to be 50 instead of 100,
Ningyu, which file do you prefer? Which upload type?
Well, I've already created it.
Oh, you already did?
Yes.
Oh, you're fast. I was about to create it. Okay, then. That's fine. I'm not gonna. I just looked this moment and there was nothing. Okay.
You can check again.
That's
Should be.
fine.
Should be.
Yeah. Oh, okay. I was looking here and I can see it. All right, excellent. So assignment is already up there, so if you complete, you can.
And move it to please.
That's easy to do. So ideas, how do you plot a circle? What's the one way to parameterize? Okay, up half and bottom half works, so we have x's, right? That I kind of, how do I get those x's? And I use which function? Linspace works excellent. It could also be a range, however you like it. You get yourself points. And then you plot the upper half, because if my x is on the bottom, then upper part is square root of 1 minus x squared. And the bottom half is minus. That works. What's a faster way? To just use one parameter and ask for 100 points immediately. By angle. What is true for points on a circle? Cosine and sine of an angle to the point describe its x and y, right? So that's another way. Is basically my x is radius, in this case it's 1, cosine of angle, let's say alpha or theta, however you want to call it. Okay? And this is my alpha. So this coordinate here is x, which is our cosine alpha, and this one here is our sine alpha. Either way is fine. Yeah, I'm just saying there's always multiple ways. This one's maybe slider to type, faster to type in. Okay, so hopefully nobody is now stuck on how to create the points. Now I just want you to plot. Again, however you started, it's all good. You have options. There's a parameter that describes the width of the line. Normally it just shows up as a default. Any circles plus? Yeah. All right. And is it even? Yeah. That works. So there's often multiple ways how to. So you have a little bit of an A. So try doing either axis or something, or square, or something like that. And you basically make this more of a circle because right now you just make a choice. Nothing's wrong with it, but it's just axis.
That's right here.
Math dot square root of 1 minus.
Oh, you gotta make it red. And you gotta change the font size.
If you do axis type, because again, you take a choice. You might be happy with it, but if not, then you don't
Oh, the radius.
what I will ask you in a test situation, for instance, I will not test you on knowing how to make these axes equal or square or anything like that. What I want you to know is that everything that you see, you can also modify. You just sometimes will have to go on a search how. So there are these defaults that show up. So it's going to refigure out the plot for you. Oftentimes it's going to work just fine. If you're not happy with it, or you want it to always look the same on your computer or my computer, whoever it is that you're sending it to, then you have to go into nitty-gritty of finding what is the parameter there, how you set it to work. Okay? That's all I want you to know. However, I want you to know how to label your axis, because that's important in engineering situations. If you just plot some numbers, they mean nothing without actually labeling what it is. Okay? So setting a title, font sizes, I just want you to know that you can change them. That said, if you in your future courses give a plot to Dr. Balhoff that has very small font sizes, good luck. Okay? He doesn't like that, right? How many points off? 100. 100. Okay, so people have to be able to read whatever it is that you're showing them. When you're sending something in email, that's fine, but if you're doing a PowerPoint presentation, it has to be readable, or else nobody's listening to what you're saying. Okay? So you have to understand that. All right? So what was the parameter for changing line width? It's called line width. Right? So often it actually makes sense, right? And often if you type in the question in your search, the result will pop up. Matplotlib has a lot of examples online. You might actually just visually pick the one you like and try to recreate when you need a nice plot. So having nice plots is important. I'm not going to insist on it in this class, but as you go in your classes forward, plotting something in a nice way is important for your communication, for people signing up for your idea. Okay? So I want you to know you can always plot things nicer. All right. Here is, I'm not going to go through this example, but you have it if you want to. This is how to be very nitty-gritty about every font size that shows up on your plot and make it show up the very same way on every computer. Okay? So you can set font size. So I picked 3 different sizes and I set font size for every basically text object that shows up. Font itself, axis, those ticks on the axis, they're called ticks. Okay, X ticks, Y tick, legend, and figure overall. Okay, you can modify them all. And then once you actually set them precisely to what you want, these are pretty large, 16, 18, 20, those are pretty large font sizes. Okay, then when you plot things, these are the ones that are going to be used. Otherwise, it's whatever default is set for you. Okay? So again, I'm just saying, you can be as particular as you'd like. I'm not going to test you on this. This is for Dr. Balhoff's class. Okay. The reason why these font sizes vary and the results vary for everybody's different browser, different computer, is that computer is trying to optimize with whatever figure size is set for your browser or whatever it is that you're plotting. So this is another hack, okay, is that you set the figure size to be precisely certain size, and then whatever you're typing in that, like labels, will be relative to that figure size, okay? So that's another way. Okay. Let's move on to some cooler plots. So XY plots, graphs, are the most common ones. However, often we have information that depends on more than one variable, so at least two. So I'm plotting some variable versus two of them, for instance. Can we move on? Are we still plotting that circle? Trying to? Do you need another minute? So, okay, let's take another minute before I start talking about something else. And then please submit it. And you 3 months after care, because if you read it again, you know what you did. Right. Uh-huh.
You said you only make this type of actions, right? Yeah. And then when you put the space, that means if I make this one smaller, then it's
Yes. Remember how arrange doesn't take the last remember that endpoint business? So it ended up just like 0.01 below. Yeah, so usually it's spacing. But then you need the number of points, not 0.01. Not spacing, but number, like spacing. Starting point. Submit it online, please. You're done with that.
I'm seeing how far I can push it. Like just leave us? Download it as an literally just a minute as an
You did it differently, but you did it with the widespread one, and I did it with the
or just download it.
widespread.
I'll just download it. Download it as a
So what is the key? Yeah, we use
it's not going to work.
Alright. I think you can wrap up. If you're, in terms of plotting, if you're doodling and have nothing else to do, go to Matplotlib online and see how some of these pretty plots look like. And they all have codes and examples. So don't be afraid of taking the example that is set there and modifying it for your purpose. Okay. Yes.
Minimize it on Python. With .py.
I think he prefers picture or something.
Oh,
So
yeah.
PDF
So you don't have to run.
would be better. Yes, then it's easier to grade.
Right.
All right, let's move on to something more exciting, 3D plots. Okay? Our core problem in any plot is having points to plot, exact points that you want plotted. Okay? Now, when I have a graph like this, okay, that means on this surface that I like to plot, and this could be a terrain, it could be top of your reservoir. It could be oil water line and subsurface, right? So basically, having this or points on this is key. Where are those points? So we're going to start simple. We're going to start simple by just having a function that we want to plot. But the key problem is, in this thing, I see some sort of a grid. In essence, for a computer to plot this, you have to have physical points values for all of these points that I'm showing here. Okay? Let's see if my mouse is working properly. Can you see it? Yeah. So this point, and so forth. Coloring of this graph and that cream on top, that's easy. But I have to have points. So in 3 dimensions, I have to have x, y, and z coordinate or every point. And I see them on this grid. Is grid 1-dimensional, 2-dimensional, 3-dimensional, the grid itself?
just the.
Technically, it's a 2D grid just warped a little, right? So at least I have to these x and y's, I have to have on a 2D grid, okay? And then z I can compute if it's a function, right? So technically, if I have z of xy, that is minus x exponential minus x squared plus minus y squared, which is what's plotted here, as some function of x and y, okay? Then I have to have a grid of x and y's. What is a good choice to basically then, so now I have to then, even if I have that on a piece of paper, okay? Let's say that I give you a simple grid, x, y, and let's say that we are on 0, 1, and 2. Can you write down x and y coordinates of all of the points here on the board? Not to scale, but okay, bear with me, okay? So what are x and y coordinates of this point? This point? 1, 0. 1, 1. So I have to communicate this now to a computer and also compute whatever z's for those points, right? Okay. I have choices, right? Because I have 2 points that are describing x and y coordinates, 2 coordinates that are describing each point. Okay. So I can give them as a set of these double x and y things, right? Or I can visualize it sort of as a grid and put it into matrices. Yes? So one matrix could carry x coordinates for all of these. So x coordinates go as 0, 1, 2, 0, 1, 2, 0, 1, 2. Yes? So sort of 0, 1, 2 repeated. And my y coordinates, they go as 0, 0, 0, 1, 1, 1, 2, 2, 2. Yes? Do you see that? So that's what we actually do. For these plots in 3D, we will create matrices of x and y coordinates, and then we will compute matching z's and give that as well. Okay? So that's essentially going to be something like this in a more general way. Right? So I'm going to have a matrix X that for every point on a grid will have X coordinates of those points, and then Y coordinates for the points. So in the same location, I'm going to collect X and Y in the same location for that grid. And then we know that we can manipulate with arrays. So for given X and Y's, I can then compute my Z really easy as long as I have a formula. Does that make sense? So let's give it a shot first with some examples. I have them on the... And there's actually a mesh grid that creates these matrices, but I'm going to start working in my Jupyter so you can follow. So let's start playing with that. Okay, so I'm going to create myself a new notebook. I'm going to call this one Lecture 2.5 3Dplots or Plots 3D. There's a version of this already on Canvas for you that has a little more comments that I get the time to type in. Okay. So first things first, we're going to import NumPy as NP. You can kind of do that even without thinking. Just type it in. And then let's give myself, so the way to create these is that I have x's, okay? And these x's, in this case 0, 1, 2, they have certain range. So I can use linspace to create them, okay? So let's do x is np linspace between 0 and I don't know, I'm going to go a little larger, 5. And let's do 5 points. Let's see what we get out of this. Yes, I do. How did I even type it in? I don't know. What did I? Oh, okay. I want whole numbers. 1, 2, 3. I want a nice grid of whole numbers. Okay. And then I'm going to create a similar y. Okay? Now I want to kind of cross them, okay? And if you notice, I could technically go and create a matrix. So if you notice for x dimension, we had 0, 1, 2, 0, 1, 2, 0, 1, 2. So I could just repeat this. 0, 1, 2, 3, 4, 5 I have on my computer. And for y's, I could just realize that, okay, I have 0, 1, 2, 0, 1, 2, 0, 1, 2. So they're basically columns of the same matrix. Right? So I could do that manually, but good news is that there is a mesh grid function that will do that for you. And it's called NP mesh grid. So it's already pre-programmed. Now, before I print it, there's something curious that I typed in. I said x comma y equals to NP. So far, we used functions that would just do something, okay? Typically print it on a screen or plot it or something like that. In this case, it seems that the function is sending something out, okay? And I'm grabbing it and storing it. So just like you can have different inputs that go into a function, and functions are actually one of our next topics, just like you can have different inputs that go into the function and you just have commas in between them, you can also have outputs. That function could create something and send you back instead of just printing or plotting. Right? And you can grab that something and store it. How many outputs come out of the function? That depends on the function. I have to know that. I have to know the syntax. In this case, there are 2 outputs. I could decide to grab them all into one, but then it's going to create this composite object and it's going to store everything that is coming out in those 2. Or I can grab them every time. Basically, I have multiple objects in Python. I just separate them with comma and it's going to operate with them. Okay? So I'm basically storing 2 outputs into x and y, and I'm printing them just to see what happens. And I'm going to turn off printing of this x and y because that test is done. So I can see that this first function, and you have noticed that, or maybe you didn't, you can actually send to print anything. So I'm going to give it x just as a text for me, for the human reader to know that x is what's printed first. So this x is indeed this 0, 1, 2, 3, 4, 5 repeated for as many y's as I have. And my y has 0, 1, 2, 3, 4, 5 repeated as columns for as many x's as I have. And do we see that spatial arrangement? Eh? So for every x, I have a column 0, 1, 2 repeated. Yes? And the only other thing that is kind of curious, but you have to know about it, the way we print plotting axis is always x grows this way most of the time. Okay? On the screen, you start in that end, and you grow down. Okay? 0, 1, 2, 3, 4, 5. It grows down. Yes? So it's kind of visually mirror image of this. Did everybody catch that? It's kind of important because you can sometimes flip things in your brain. So on that plot, my y grows up. In this y grows down visually. Yes? It's a matter of choice that is set, and there's no right and wrong.
Yeah,
No, it's still going to work with it, but that's where it visually puts it when you're growing as a matrix. You grow. When it's printing it down, right? Okay, excellent. So now I have my x and y's. I can work with them. I can do functions. I can compute with these numbers. How would I just square every number in my matrix X? Or this is a square, right? And we know by now already with NumPy, it's going to work with every element of this. So every element got squared. I can do whatever. Sine, cosine, exponential, whatever square root. Okay? Okay. So now that you know the mechanics of it, I want you to vary it and show that you understand a little. So I want you to create XY coordinates in -5, 5 by -5, 5. So slightly different range than the one that I plotted. And for those XY coordinates, create 2D mesh and store in matrices X and Y. This is the process that we just did right now. And then compute Z, which is technically a function of XY. That is 2 minus x squared minus y squared. So for every point of these x and y's, compute it. And then we're going to plot it. But we have to have those points first. So again, before we want to plot, we want to create this x, y, and z's. And they're going to be stored in matrices. So really, function v that we are plotting is 2 minus x squared minus y squared. But I kind of have to come up with a grid of points. This green just should be banned. Green is not visible. So I gave you examples on 0, 5. You gotta modify them. Okay? Did everybody get this? Okay? So basically, between minus 5 and 5, how many points is your choice? I picked 10. Mesh grid gives me those matrices, and then I compute with them corresponding z values. We're going to actually plot this next time.